bios.in.
Hello guys, pleasant greetings to the learner in you. This video is the second part of the series Assembly. Its main focus is to guide you on the basics of assembly language along with registers. Make sure that you have watched the previous videos of this series to understand this video better. In the upcoming slides, I will try to tell you about registers along with its basic instructions like move and LEA, and also arithmetic instructions including add and sub. Let us begin with registers. Registers are memory storage areas inside a processor used to store data or instruction or an address. This data can be stored in a register or in a memory location, but the difference comes in the access time. Registers are very fast since they are closer to the processor. Memory access takes approximately 50 nanoseconds, while in case of a register, it takes 1 nanosecond or less. Thus, the process execution time is faster. Let us know more about registers. This is in accordance with 32-bit architecture. The following are the general purpose registers: EAX, EBX, ECX, EDX, ESI, EDI, EBP, ESP, and EIP is an instruction pointer. Let's understand the EAX better. It is basically a 32-bit register. It is divided into two parts, that is 16 bits each. The lower one is called AX, which ranges from 0 to 15. This AX can further be divided into two of 8 bits each, which is AL ranging from 0 to 7 and AH from 8 to 15. It is the lower and higher portion respectively. The similar explanation goes for EBX, ECX and EDX. Register EAX is extended accumulator register. EBX is extended base register. ECX is extended counter register and EDX extended data register. Next is EIP, ESP and EBP. We can relate to the stack and understand it better. These are the pointer registers. EIP stores the address of the next instruction. ESP is the stack pointer, always points to the top of the stack. EBP is the reference pointing to the base of the stack. As you can see, the stack grows downward, so as per definition, ESP is at the top and EBP is at the base. EDI and ESI are related to loops and arrays, where EDI is the destination address, while ESI is the source address. Now let us see the basic instruction move. It is to move the values from the source to the required destination. For example, if EAX has the value 1 and EBX has the value 2, to move this value currently in EBX to EAX, we can use move instruction. As shown by the instruction move EAX, EBX, this will result in the value of EAX to be same as EBX, that is 2. But you will also come across this syntax move mode source, mode destination. This is the gas syntax. As you can see, it has the source first, the destination. As shown in previous slide, we will be dealing with Intel syntax. Next is LEA, which stands for load effective address. It is used to load the address of the source to the destination. Let the registers have the value as shown in the black box. Now for the given instruction LEA EAX, ECX plus 8, the value ECX plus 8 is loaded to the EAX. No dereferencing happens here. Hence, the value is as it is loaded. The term dereferencing means that the value present in the address is loaded, not the address itself. So the difference is, in case of move instruction, dereferencing occurs. That is, if in the same instruction LEA is replaced with move, then the value present in that memory address is loaded to EAX. Now comes arithmetic instructions. First is add, which is to add the required values. For example, if EAX has the value 1 and EBX has the value 2, then add EAX, EBX will add these values and save the result to the first register. Therefore, EAX will be EAX plus EBX. Hence, EAX is equal to 2 plus 1, that is 3. Next is sub, which is for subtraction. If the EAX has value 3 and EBX has value 2 in it, then sub EAX, EBX will subtract EBX from EAX and store the result to the first register. That is, EAX is equal to EAX minus EBX. Therefore, EAX is equal to 3 minus 2, which is equal to 1. Hence, the register EAX has now the value 1. Let's see a demo of the assembly program to add two numbers. So this is the program to add two numbers. This is the main of the program, and this is the function prolog. These two instructions are move instructions. This move instruction moves the value at the address of input 1 to EAX, and the same goes with the second instruction also. Then the two are added and EAX is pushed onto the stack, and then the printf function is called. These two are the function epilogues. Now we'll check out the execution step by step through GDB. So this is the command to compile a 32-bit program. Now GCC, and then we'll just run the program. Okay, yes. So this is 3. This 3 came because what we the values we initialize as input 1 and input 2 are 1 and 2. So once we add this, the output will be 3. So we got the output as 3. Now we'll go and check it out through GDB. This is the main. Yeah, now we'll set a breakpoint at main. This is the instruction to set a breakpoint. Now we'll run the program. Yes, so we'll push EBP, that is function prolog, and then we'll move the value at the address so and so to EAX, that is input 1. You will find a difference because it's now there is no input 1 and input 2. Whatever we initialize in the data segment, they have a specific address. Like everything has a specific address. Now this shows data segment address so and so. Now next, yes, the value of input 1 is moved to EAX register. Same goes with EX, that is 2, EBX, and then add. So both are added, and yeah, EAX has the value 3, which is 2 plus 1, and then the value of EAX is pushed onto the stack. As you can see, 3 is pushed, and then the format specifier is pushed, this, and now the printf function is called. Yes, now we'll go through the function epilogue, and then yes, exit it. So we can see, as you can see, 3 is printed and we have successfully exited out of the program. So that was all about it. We have successfully compiled a program. I hope you understood something about things about the arithmetic operations out of GDB. And finally guys, thank you guys for your attention. I hope the short video helped you. If you have any queries or questions, feel free to contact us.
Thanks for watching this video. Please leave a like and comment if you have any suggestions. Subscribe to the channel for more exciting content. Make sure you follow us on Twitter and Facebook.